Hello, everybody, and welcome back. We are now in chapter 16. We had a little bit of issue with the ordering of the text on our newer edition. This is now chapter 16. We have corrected chapter 14 already online. We are now dealing with psychological influences on personal probability. We live in a scary time right now with everything going on. I figured I would show you a scary pumpkin to start the class. We are inferring causation from correlation. We know that's scary. That's not something we can do. So let's get started. Our first thought question. During the Cold War, readers were presented with the following test. Which of the following seems the most likely to occur within the next 10 years? An all-out nuclear war between the United States and Russia, or an all-out nuclear war between the United States and Russia in which neither country intended to use nuclear weapons but were dragged into the conflict by a third country. So let's see, what seems the most likely? Well, if we consider our options here, an all-out nuclear war or an all-out nuclear war because of something else. We're going to talk about which one of these is actually the most likely coming up. Our second thought question. Which is the more likely cause of death in the United States? Homicide or diabetes? This is typically where I'd ask the entire class to raise their hand. Which one do you feel, homicide or diabetes? We would write down the answers and then discuss them. So just write down your answer so we can refer back to it later. How did you arrive at your answer? Well, unless you had maybe a friend or a loved one that died as a result of one of the two, the way that you most likely arrived at your result was through what you read in the media, what you see on television. We're going to discuss the answer to this coming up. Do I believe that people are more likely to pay to reduce their risk from 95% to 90% or from 5% to 0? Both of these are a 5% risk reduction. Which of these is going to be the preferred option among the participants? We're going to see with the certainty effect that second option is the preferred option. So starting our chapter, some situations are not repeatable. So a personal probability assigns a probability based on the individual's educated guess, how they feel that the events are likely to occur. This is subjective. But just because it's a subjective probability, that doesn't mean it doesn't follow our typical probability rules. Of course, the smallest possible value we could assign is still 0, a 0% chance. The largest possible value being 1, a 100% chance. The certainty effect. The certainty effect shows that people are more willing to pay down to reduce their risk from some fixed amount to 0 than they are to reduce from that same amount to some non-zero value. That is what we referenced in our third thought question. People are more willing to pay down if they are certain that there is now no risk than they are to pay down even if they're reducing by that same factor. We're still reducing by 5%. So let's look at our first example. Students were asked if they wanted to purchase this insurance option that costs half as much as regular insurance, but only covers losses with a 50% probability. 80% of them were not interested. Although, if you were to calculate the expected value, again, that theoretical average, this becomes the exact same as a typical insurance policy. The lack of assurance, the lack of certainty, made the payoff unattractive. 80% were not interested because they weren't certain of the outcome. So people are more willing to pay down to get to 0. That is the certainty effect. The pseudo-certainty effect. People are more willing to accept a complete reduction of risk on certain problems and no reduction on others than to accept a partial reduction on all. So let's look at our example here. A vaccine questionnaire. We all know how important vaccines are at this point. Form 1. The vaccine is available for a certain disease that afflicts 20% of the population, and it works half of the time. 40% of the people would take this vaccine. In Form 2, there's 2 strains, each afflicting 10% of the population. The vaccine is completely effective against one, but has absolutely no protection against another. 57% of people would take this vaccine. Both Form 1 and Form 2 reduce the risk from 20% of the population to 10% of the population. They're just as effective as the other. But because Form 2 takes a 100% effective against one of the 2 strains, people are more likely to take that. That's a 17% change based on this pseudo-certainty effect. This is something we have to consider when people assign personal probabilities. Onward, and again, we're in chapter 16. These are all misnumbered because of the change in the ordering of our textbook. Chapter 16, still. How personal probabilities can be distorted. The availability heuristic. It says, there are situations in which people assess the probability of an event by the ease in which the circumstances can be brought to mind. This judgment heuristic is called availability. Let's go back to our question. Which is more likely that you die of diabetes or that you die of homicide in the United States? Again, what do you see more of in the media? What do you think about more often? Most likely, homicide. But if we were to look at the actual numbers from 2000, not the most recent numbers, but again, this is from 2005, so recent at the time. Nearly 6 in 100,000 deaths were due to homicide, but almost 25 out of every 100,000 were due to diabetes. You were more than 4 times likely to die from diabetes than you were from homicide. But what receives attention in the media? Homicide. So if you were to assign a personal probability, that's going to be slanted because of that availability heuristic. That's what you think of more often. Following on that pattern, have gun homicides increased or decreased over time? If you're watching the media, if you're reading publications, if you're watching the news, gun homicides are constantly being brought up. But if we look at the actual data from the CDC, from 1981 until 2010, these gun homicide rates were cut nearly in half. And again, these are rates per 100,000 people. It wouldn't be an accurate way to compare if we were looking at just total number because of the changes in our population size. So again, we're looking at rates per 100,000 people. Most of you probably would have assumed that the values were increasing, but that's just not the case. A detailed imagination. Risk perceptions are distorted by people having a vividly imagined certain events. Anybody here who has worked in sales has used this to their advantage. Okay. It says a salesman convinced you to purchase a $500 extended warranty for your new car by explaining a situation in which the air conditioner fails. And just by the air conditioner failing alone and having to pay for that, That costs more than $500 by itself. But the problem is, it's extremely unlikely that the air conditioner actually would have failed. So they painted a picture, they explained a scenario in which you could imagine the events unfolding and having to pay more than $500, but those events were unlikely to actually occur. Anchoring. Risk perception is distorted by providing a reference point. This reference point we call an anchor. Anytime that you see a survey, anytime that you read a polling question that's provided with an anchor, there's typically a reason why they provide you with that anchor. It's slanted in one direction or another. The issue with an anchor is that values tend to stay close to the anchor that's being provided. So if I give a low anchor for our survey question, what is the chance of nuclear war between the United States and the Soviet Union? If I gave a low anchor of only 1%, the responses tend to be close to that low anchor. But if I gave a high anchor of, say, 90%, the responses tend to be closer to that higher anchor. You're giving them a reference point, and the values stay close to that reference point. The best estimates occur when you have no anchor at all. The no anchor estimates tend to be somewhere in between the high and the low. The representativeness heuristic and the conjunction fallacy. The representativeness heuristic leads people to assign higher probabilities than warranted to scenarios that are representative of how they or how we would imagine things would occur. Let's go back to our very first thought question. In 1993, if the United States and Russia were to have engaged in a nuclear war, how does it make sense that the events could have occurred? It could have been and a reasonably thought to be because of some third country like Iraq or Pakistan. But what we can't do is assign a higher probability to that. Just because when we paint the picture, we say that makes sense leading from A to B. This jumps right into our conjunction fallacy. And we're going to go back now to the conjunction fallacy. When detailed scenarios involving a conjunction of events are given a higher probability than a single event by itself. The single event would have been the nuclear war between the United States and Russia. The conjunction is the nuclear war because of some third country. This second bullet point is a subset of the first. This is only one of any possible number of reasons why the nuclear war could have started. So the simple event always has to have the larger probability than the conjunction event. One is a subset of the other. Let's look at a second example. Linda is a 31-year-old, single, outspoken, and very bright. She majored in philosophy, and as a student, she was interested in issues of discrimination and social justice. She participated in anti-nuclear demonstrations. Which of these is the most probable event? That Linda is a bank teller, or that Linda is a bank teller who is active in the feminist movement? Think about our Venn diagram that we discussed in chapter 14. In one circle, we have Linda being a bank teller. In another circle, we have Linda being involved in the feminist movement, and then we have the intersection of the two. The larger value here has to be the simple event, the bank teller, because the intersection is only part of Linda being a bank teller. It's a subset of that. However, when we asked a group of naive undergraduates, 86% actually thought the second was the most probable. And again, this is because of the conjunction fallacy. Forgotten bases. It says representativeness heuristic can lead to people ignoring information about the likelihood of various outcomes. We were given a group of 100 people. 30 of them were engineers, 70 of them were lawyers. We were asked, what is the likelihood that a randomly selected individual would be an engineer? Nearly 30% of people guessed engineer. And it should have been exactly 30%, right? 30 out of 100. Then we were given a description and asked, how likely is it that this person is an engineer? This description said that Dick is a 30-year-old man. He is married with no children. He is a man of high ability and motivation. He promises to be quite successful in his field. He is well liked by his colleagues. Nowhere in this paragraph did we say that Dick is an engineer, that Dick is a lawyer, or even give any indications that they tended towards one field versus another. However, after this paragraph, the median response is that 50% of the people thought that Dick was an engineer. Remember, we're still basing this on the fact that there's 30 engineers out of 100 people. The base rate is still 30%. Because we didn't give any information explaining that Dick was an engineer or a lawyer, it's still a 30% chance. Optimism and overconfidence. So it says the majority of individuals believe themselves to be better than average drivers, more likely to live past 80 years old, less likely to than average to be harmed by certain products. Today's day and age, probably less likely to contract the coronavirus, and so on. So it says, on our sixth example, on average, students rated themselves 15% more likely to experience positive events and 20% less likely to experience negative events. When assigning a personal probability, people tend to overinflate their positives and underinflate their negatives. A reluctance to change. The reluctance to change one's personal probability assessment on or belief based on new evidence. So, if new evidence or new data comes out and you still put your foot down and say, no, this is my probability, this is what I believe, even if that new evidence should sway that probability, we would call this a reluctance to change. That reluctance to change couples well with overconfidence. The tendency for people to put too much confidence in their own assessments. When people venture a guess about something for which they are uncertain, they tend to overestimate the probability that they are correct. If I gave you a multiple choice question and you had 4 options, A, B, C, or D, what is the probability that you guessed correctly? Should be 1 in 4, right? But again, people overestimating themselves, overconfidence, you may say, no, I actually think that there's actually a 1 in 2 chance that I guessed correctly. Even if it was a complete guess, you overinflate, you overestimate your own personal probability. So this is our 7th example. We asked people hundreds of questions on general knowledge. One example is, which magazine has a larger circulation, Time magazine or Playboy? I don't even know that Playboy is still in circulation. This is a little bit older of a question. You can see from 1977. And then we were asked to rate their odds in which they were correct. A 1-to-1 odds is a 50%, right? The number in favor versus the number not in favor. A 1,000,000 to 1, which is explaining that 1,000,000 times I think I'm correct for every one time that I'm incorrect. That's a virtually certain outcome. What's interesting is that the more confident that the respondents were, the more likely that their answers were incorrect. So as people assigned a higher confidence level, they were actually less likely to be correct. One simple solution to avoid the overconfidence issue is to consider reasons why you might be wrong. If you were to list out the reasons why you might be wrong, you may bring down your personal probability. That may help to mitigate that overconfidence. Calibrating personal probabilities of experts. Professionals who help others make decisions, like doctors or meteorologists, often use personal probabilities themselves. Based on their educated guess, what did they feel? If they had a perfectly calibrated personal probability, what that would mean is if the meteorologist said that there's a 30% chance of rain, for every 100 times that they said there's a 30% chance of rain, it would rain 30 times, meaning it would not rain 70 times. Let's look at an example. Here we have two sets of data. With the open circles, we have our weather forecasts. On the horizontal axis, we have the predicted probability, their personal probability, and then the actual probability based on the relative frequency. Taking all of the actual data and comparing. Let's see, when the meteorologist said that there was a 10% chance, the actual forecast was approximately 10%, right? 20% chance, approximately 20% of the time it actually rained. This is not perfectly linear, but this would definitely have a strong positive correlation. This R value, our correlation coefficient, would be very close to 1. Where does the meteorologist tend to deviate? Once they got into that 100% chance of rain, that's where we're slightly off of that straight line. But these were pretty strong personal probabilities, very strong educated guesses. Now let's compare that to a physician. The relative frequency of the predicted probability versus the physician's probability. So the patient thinking that they had pneumonia versus the physician's personal probability that they actually had it. If I look at this patient here, just under 90% chance that they think that they have pneumonia. It's about 15% of the time that they actually did. 65% chance that they thought they had pneumonia, just about 10%. So they were overestimating the chance that they actually had it. Tips for improving our personal probability and judgment. The first tip makes sense. Think of the big picture. We should always take a step back and consider the big picture, including the risks and rewards that aren't being presented to us. For example, if I want to compare insurance policies, it's not just what's the cheapest policy. It's not just calling up the general to get car insurance. We're also wanting to compare coverages as well, comparing one value to an equal value. When considering how a decision changes our risk, we have to first find the baseline. We always want to have a baseline value that we're going off of. Now, it says to determine the risks on equal scale, we want to consider, say, ratios or rates. If we're considering our homicides, Homicides may tend to increase as the population increases, but the rate at which people are dying via homicide may decrease. So we want to compare the base rates. Don't be fooled by highly detailed scenarios. This is our example of the the car salesman trying to get you to buy an extended warranty by explaining that your air conditioner could break. Remembering that the excess detail actually decreases the probability that something is true. Again, to avoid overconfidence, list reasons why your judgment may be incorrect. This could provide a more realistic confidence assessment. Try to be realistic in assessing your own individual risks. Try not to overinflate our values that are positive and underinflate our negatives. Don't fall into the trap of thinking that bad things only happen to other people. Watch out for anchoring. Remember, if there's an anchor there, there's typically a reason for it. They're trying to get you to tend towards the anchor. And finally, if possible, break the event into pieces. If we go all the way back to our first thought question, I could assess the probability that the United States would be in a nuclear war with Russia, and then I could assess the probability that the cause of that nuclear war would be by this third party. We can break these down into individual events. So, this is our Chapter 16 work. Again, Chapter 16. This is the first of our 3 short chapters that I'll be posting. If anybody has any questions, please reach out to me. WebAssign is the preferred way to reach out to me, but if you send me an email, I will respond to that as well. Stay home and stay safe, everybody.